Picture this. It is the middle of the night, and you are standing behind a telescope in your backyard, breath fogging in the cold air, watching a pale gold planet hang perfectly still in the eyepiece. That planet is Saturn, and right now its rings are doing something they have not done in 15 years, and will not do again for 15 more. Because of a tiny wobble in Saturn's orbit, the rings you are looking at tonight are thinning out before your eyes, and in the next few years they will look nothing like this again, not for a very long time, and maybe, on a timescale almost too big to imagine, not ever. So if you want to understand why the most famous rings in the solar system are quietly changing shape right now, and maybe catch a front row seat to it happening, stick with me for the next few minutes, because trust me, once you know what is coming, you will never look at a picture of Saturn the same way again. Most people think of Saturn's rings as permanent, something fixed, a crown that has always looked the same and always will. They picture the postcard version, the wide, bright, tilted halo, sharp as a knife's edge against black space, exactly like it appears in almost every photo ever taken of it. But that photo is a snapshot of a single moment, in a story that is actually always moving, always shifting, and closer to its ending than most of us realize. Stick around, because by the end of this video, you are going to understand Saturn in a way almost nobody else watching the night sky right now does. Let us pull back now and start from the beginning, because to understand what is happening to Saturn's rings today, you first need to understand what most people believe about them, and why that belief is not quite the whole truth. Here is the assumption almost everyone carries around, without ever really questioning it. Saturn has always had rings, it will always have rings, and the way they look right now is simply how Saturn looks, and always has looked. It is such a natural assumption that most of us never even think of it as an assumption at all. It simply feels like a fact, the same way we assume the sun will rise tomorrow, or that the ocean has always been salty. Saturn is the sixth planet from the sun, a giant ball of gas so light that if you found an ocean big enough, it would actually float. It is nearly 10 times wider than Earth, so big that you could line up more than 9 Earths side by side across its middle and still have room to spare. It takes sunlight, traveling at the fastest speed anything can move in the entire universe, over an hour just across the gap between the Sun and Saturn. That is how far away we are talking about. But the part everyone remembers is not the planet itself. It is the rings.
280,000 kilometers across if you measure the outer edge, which is almost 3/4 of the distance between the Earth and the Moon, laid out flat in space like a giant glittering plate. And here is the detail that surprises almost everyone the first time they hear it. Those rings are not solid. They are not some kind of glass or metal disc. They are made of billions and billions of individual chunks of ice, some as small as a grain of sugar, some as big as a house, all orbiting Saturn together, all catching sunlight, which is why from far away they look like one smooth glowing band. Imagine a snowstorm, frozen in place, stretched out into a ring wider than the distance from New York to Los Angeles, almost 30 times over, and you start to get a sense of the scale we are talking about. Now, shrink that picture all the way back down to something familiar. Picture the frost that forms on the inside of a freezer, thin, sparkling, delicate. Saturn's rings are that same kind of fragile ice, just spread across a stage bigger than most of us can properly hold in our heads. And despite being spread across a space wider than the gap between Earth and its moon almost twice over, the rings themselves are shockingly thin. In most places, they are only about 10 meters tall, roughly the height of a 3-story building, which means if you somehow shrank Saturn down to the size of a dinner plate, the rings would be thinner than a sheet of paper laid across it.
That contrast, unbelievably wide but almost impossibly thin, is part of why the rings have fascinated stargazers for centuries. Something that delicate should not be able to survive for long, caught in the gravity of a giant planet, constantly tugged and stretched, and yet there it hangs, appearing steady, night after night, year after year. Scientists have been trying to figure out where all that ice came from for a very long time. One leading idea is that the rings are the leftover pieces of a moon that wandered too close to Saturn and got torn apart by its gravity. Maybe 100 million years ago, maybe longer. Another idea is that a comet or a small icy world got shredded the same way, its pieces spreading out into the wide, flat halo we see today. Either way, the picture most textbooks paint is one of permanence. Saturn's rings, the story goes, have probably been there since not long after the solar system itself formed, 4.5 billion years ago, quietly circling the planet while empires rose and fell and dinosaurs came and went down here on Earth. That is the assumption. Old, stable, basically unchanging, on any time scale a human being could actually notice in one lifetime. And for a long time, that is exactly what scientists believed too. The rings looked ancient in every photograph, from every mission, going all the way back to the first fuzzy telescope sketches in the 1600s, when astronomer Christian Huygens first realized Saturn was surrounded by a flat ring rather than a strange pair of handles, as earlier observers had guessed. Even the two Voyager spacecraft, which flew past Saturn in 1980 and 1981 and sent back the first truly close-up pictures anyone had ever seen, only reinforced the idea. The rings were beautiful, complicated, layered like a record album, but nothing in those pictures screamed that they were changing in any hurry. So by the time most of us were kids looking at pictures of Saturn in a textbook, the rings had settled into our imagination as something eternal, a fixed feature of the solar system, as permanent as the planet itself, as reliable as sunrise. Even the two robotic Pioneer probes that visited Saturn before the Voyagers, back in the late 1970s, sent home pictures that fit the same story. A calm, orderly system of ice, banded and layered, looking every bit as ancient as the planet it circled. Museums built scale models of it. Classrooms hung posters of it. An entire generation grew up assuming that if you could somehow live forever and check back on Saturn every single year, the rings would simply look the same, decade after decade, century after century, without any real change at all. But that picture is about to change, because a much closer look, one that took decades to actually get, found something that the old photographs could never have shown. Before we go further, if this is the kind of story that makes you want to see where else our assumptions about space turn out to be only half right, go ahead and follow along here, because there is a whole universe of moments just like this one still waiting to be unpacked. One planet, one moon, one mystery at a time. And here is something you can do right now that actually helps. Drop a comment describing the exact moment your own idea about Saturn's rings just got turned upside down, because comments like that are literally how future episodes on this channel get chosen. The story really starts to shift in the late 1990s, when a scientist named James O'Donoghue, then early in a career that would eventually take him to NASA's Goddard Space Flight Center, started digging into a strange detail buried in old Voyager data. The old flybys had noticed something odd, something almost too small to matter at first. There seemed to be a faint haze of charged particles raining down from the rings into Saturn's upper atmosphere, near the planet's equator. At the time, nobody thought much of it. It looked like a minor curiosity, a little bit of static in an otherwise stable, ancient system, the kind of small detail that gets a footnote in a paper and then gets forgotten. Then, decades later, the Cassini spacecraft arrived at Saturn in 2004 and stayed there, orbiting the planet and its rings for 13 straight years. Cassini was not a quick flyby like Voyager, it was a long-term resident, and that meant scientists finally had the tools to watch the rings and that strange rain over time instead of in a single snapshot, the way you can only really understand a river by watching it flow, not by looking at one photograph of it. In its early years at Saturn, Cassini mostly focused on mapping the rings in incredible detail, counting waves and ripples in the ice, and photographing tiny moons tucked inside gaps that nobody had ever seen clearly before. What they expected to find when they eventually turned their attention back to that old, strange signal from the Voyager years was more of the same. A slow, essentially frozen system, the same ancient rings just sitting there, exactly as stable as everyone assumed, quietly orbiting the way they always had. What they actually found was rain. Real rain, just made of something you would never expect, falling from the rings straight down into the planet. Tiny charged particles of water ice, electrically charged by Saturn's magnetic field, were peeling away from the rings and spiraling down along invisible magnetic field lines into Saturn's atmosphere, where they simply burned up and vanished, the same way a shooting star burns up in our own sky. It is a little bit like watching frost melt off a car windshield in the morning sun. Except the frost is enormous rings of ice around an entire planet, and instead of melting into water, it is getting pulled away into the planet itself, drop by drop, forever, never to return to the rings again. In 2018, James O'Donoghue and his team published their full analysis in the scientific journal Icarus, using data gathered from Cassini's final, closest orbits, the ones where the spacecraft actually dove between the planet and its rings before the mission ended. Their number stopped a lot of scientists in their tracks. The rings, they calculated, are losing enough ice water to fill an Olympic-sized swimming pool every half hour. Picture that for a second. Every 30 minutes, while you are doing something as normal as watching this video, a swimming pool's worth of Saturn's rings quietly disappears into the planet, and has been doing that, probably, for a very long time, long before anyone on Earth even knew rings existed. At that rate, based on the Cassini data, the researchers estimated the rings have somewhere between 100 million and 300 million years left before they vanish completely, at least in their bright, rain-producing form. That might sound like an unimaginably long time, and by human standards it absolutely is, but compared to the 4.5 billion year age of the solar system, it is shockingly short. It means the rings are not ancient leftovers from the birth of Saturn at all. Instead, in cosmic terms, they are almost brand new, practically a decoration Saturn put on sometime after the dinosaurs had already appeared here on Earth, and they are already on a slow, steady path toward disappearing. There is more to the story, though, because ring rain is not the only thing changing what we see. Soon after the ring rain discovery reshaped how scientists thought about the ring's lifespan, another piece of the puzzle came from something much simpler to observe: Saturn's tilt. Saturn spins on an axis that is tipped over by about 26.5 degrees, very similar to Earth's own tilt of about 23.5 degrees. And just like Earth, that tilt means Saturn has seasons, just much, much longer ones, because a single trip around the Sun takes Saturn about 29.5 Earth years. As Saturn slowly orbits the Sun, that tilt causes the rings to appear to open up and close from our point of view here on Earth, even though the rings themselves are not actually moving in that way at all. They are simply being viewed from a changing angle, the same way a dinner plate looks like a thin line if you lower your eye to the table. For about half of Saturn's long year, we see the top of the rings, tilted wide open, catching the sunlight in that dramatic wide halo everyone recognizes. For the other half, we see the underside, tilted the other way, just as wide, just as bright, only flipped. And right in between those two halves, roughly every 15 years, something remarkable happens. The rings, seen from Earth, turn edge on. For a short window of time, they seem to almost vanish, becoming a razor-thin line slicing straight across the planet, so thin that even large observatory telescopes sometimes struggle to see them at all. Astronomers call this a ring plane crossing, and it happened most recently around March of 2025, when Saturn's rings appeared to thin down to almost nothing in telescopes here on Earth, before slowly beginning to open back up again over the following years. During that window, casual skywatchers looking through small telescopes sometimes reported that Saturn briefly looked strangely bare, almost like a different planet entirely, missing the wide, glowing halo that usually makes it so instantly recognizable in the night sky. Professional observatories use the same crossing as a rare opportunity, because with the bright glow of the rings mostly out of the way, faint details closer to the planet, and some of its smaller, dimmer moons, briefly became easier to spot than at almost any other point in Saturn's long orbit. Here is where the two stories, the ring rain and the tilt, start to matter together. Every single time the rings pass through one of these edge-on moments, they are a tiny bit thinner and a tiny bit lighter than the last time, because ring rain has been quietly draining mass out of them the entire time in between, cycle after cycle, unnoticed. I want to be honest with you here, because even the scientists studying this do not have every answer nailed down. There is still real debate about exactly how old the rings are to begin with, and some researchers think ring rain alone cannot fully explain everything Cassini measured, which means other processes, like micrometeorite impacts chipping away at ring particles, are probably part of the story too. Jeff Kuzi, a planetary scientist at NASA's Ames Research Center who spent decades studying Saturn's rings, has pointed out that pinning down the ring's true age is one of the hardest open questions left in ring science, because so many different processes are tangled together at once, all happening on top of each other, all at once, all invisible from Earth. Some researchers who worked on Cassini's final measurements, presented at meetings of groups like the American Geophysical Union, have suggested the rings could even be far younger than the rain estimate alone suggests, possibly only tens of millions of years old, meaning they might have formed around the same time some of the largest dinosaurs were walking the Earth. Then, in the final months before Cassini's mission ended, the spacecraft did something no probe had ever safely attempted before. It threaded a narrow gap, roughly 2,000 kilometers wide, between the top of Saturn's clouds and the inner edge of the rings, diving through that space over and over again on what mission scientists nicknamed the grand finale. Nobody was entirely sure Cassini would survive the first pass. The gap looked clear on paper, but no spacecraft had ever measured exactly how much stray ice or dust might be drifting through it, and a single unlucky collision at orbital speed could have ended the mission early. It survived, again and again, 22 times in total, and each pass let its instruments taste the actual material falling from the rings directly, rather than just observing it from a distance the way earlier flybys had to. That direct sampling is what finally let scientists like O'Donoghue turn a rough estimate into a real number, the swimming pool every half-hour figure that reshaped how the whole scientific community talked about the ring's future. In parallel with the ring rain work, other scientists studying the grand finale data found something else unexpected. The gap between Saturn and its rings was nearly empty of dust, far emptier than most models had predicted, suggesting the region gets cleared out by unseen forces faster than anyone had guessed. That small mismatch between prediction and reality is a quiet reminder that even a mission as successful as Cassini left almost as many new questions behind as it answered. Still, even with those open questions, one thing became very clear after Cassini's mission ended in September of 2017, when the spacecraft deliberately dove into Saturn's atmosphere and burned up, sending back data until its very last second, a final act of science on the way down. The rings you see in any photograph today are not a fixed ancient monument. They are a living, changing system, actively losing material, actively thinning, and slowly but surely heading toward a very different future than the one drawn in most textbooks. Between the slow drain of ring rain and the swinging 15-year rhythm of the planet's tilt, every single time you look up at Saturn, even through a small backyard telescope, you are catching one single, unrepeatable frame of a very long, very slow film. One that started long before you were born and will keep running long after. And here is where this stops being a story about one planet and starts being a story about how we look at the sky at all. Because if the rings themselves are not permanent, then a lot of the things we assume are frozen and unchanging out there are probably changing too, just on timescales too slow for a human life to notice without a spacecraft watching closely enough for long enough to catch it. If a story like that changes the way you think about looking up at the night sky, share it with the one person in your life who always says space is boring, because 5 minutes of a story like this tends to change their mind faster than any argument ever could. So what happens next? Right now, in the years just after that 2025 edge on crossing, Saturn's rings are slowly tilting back open again, and they will keep opening until they reach their widest, most dramatic angle sometime around the year 2032, when skywatchers on Earth will get one of the best views of the rings in over a decade. Enjoy that view while you can, because the 15-year rhythm will keep going. Edge on again in the early 2040s, wide open again in the late 2040s, over and over, like a slow cosmic breathing pattern that has been going on for longer than humans have had telescopes to watch it with, and will keep going long after any of us are here to see it. If you sat down and mapped out every single one of those crossings, all the way back to the first time Christian Huygens correctly figured out what he was looking at in the 1650s, you would find dozens of them already passed, quietly, mostly unnoticed by anyone except the handful of astronomers paying close attention at the time. This next one, the one building toward its widest point around 2032, is really no different in mechanics, just different in timing, and in the fact that this time, thanks to Cassini, we finally understand what is quietly slipping away between one crossing and the next. But underneath that steady rhythm, the ring rain never stops. Every single one of those cycles, wide open, edge on, wide open again, the rings will be measurably thinner than the cycle before, even if the difference is far too small for any human eye, or even a backyard telescope, to notice from one pass to the next. Space agencies have not stopped paying attention either. Scientists continue to use both Earth-based telescopes, including large observatories that watch Saturn every single year, and archived spacecraft data to track exactly how fast the rain is falling and whether it speeds up or slows down as the rings get lighter over time, because a thinner ring might behave very differently than the thick one Cassini first measured. There is also the question of Saturn's moons, several of which, like Pan and Daphnis, actually orbit inside gaps within the rings themselves, shepherding the ice particles into place with their own gravity, and as the rings lose mass, scientists want to know whether that changes the delicate balance holding those tiny moons and the ring structure around them together. Some scientists are also looking further ahead, toward possible future missions that could return to Saturn with instruments built specifically to measure ring rain directly, something Cassini was never originally designed to do, since the discovery only became fully clear near the very end of its life. A dedicated mission like that, if it ever gets approved and funded, likely would not arrive at Saturn until sometime in the 2040s at the earliest, meaning the scientists proposing it today may spend their entire careers waiting for the answers Cassini's grand finale first hinted at. By the year 2032, when the rings reach their widest tilt in this cycle, roughly 27 degrees open to our line of sight from Earth, researchers expect to have several more years of precise measurements comparing ring brightness and mass to the numbers Cassini gathered between 2004 and 2017, filling in a picture that is still, even now, only partly finished. Here on Earth, this is not just a story for professional astronomers with giant observatories. Backyard telescope owners, the same kind of person you pictured at the very start of this video, have become an important part of tracking these changes too, because every clear photo taken from a driveway or a rooftop adds one more data point to a much longer record that no single observatory could build alone. If you own even a modest telescope or you are thinking about getting one, mark your calendar for the years leading up to 2032, because that is when the rings will be tilted at nearly their widest angle in your lifetime, and comparing what you see then to whatever picture of Saturn you might snap tonight will show you, with your own eyes, a difference that took 15 years to build. There is also a quieter, more personal layer to all of this. Every image of Saturn taken by amateur astronomers today, time-stamped and shared online, becomes part of a historical record that future scientists, maybe not even born yet, will use to double-check exactly how fast this whole process is really moving. In a strange way, a person with a $200 telescope in their backyard tonight is doing something no scientist from the 1600s or even the 1980s could ever do. They are adding a precisely dated, high-resolution data point to a story about planetary change that will not be fully understood for generations. Zoom out far enough, and this single planet becomes a kind of promise, and also a kind of warning, about everything else we assume is fixed out there in space. We used to think mountains on Earth were permanent too, until geologists understood plate tectonics, the slow grinding of continents that builds and erodes entire mountain ranges over tens of millions of years. We used to think stars simply glowed forever, until astronomers understood how they burn through their fuel and eventually die. Saturn's rings are just the latest reminder that almost nothing in the universe is actually standing still. It is only moving too slowly, or too quietly, for us to notice without watching closely enough, for long enough. Somewhere out there tonight, a telescope, whether it belongs to a professional observatory in Chile or Hawaii, or a curious kid in a backyard in some quiet neighborhood, is pointed at Saturn, catching one more frame of this impossibly slow film, one more piece of a puzzle that will not be finished for another 100 million years or more. And somewhere in a research office, quite possibly at NASA Goddard, where James O'Donoghue continues to study how planets and their rings evolve over time, someone is looking at fresh data right now, checking whether the rain is still falling exactly the way the models predicted, or whether Saturn still has a few surprises left to reveal. That is really the heart of this whole story. Not that Saturn's rings are dying exactly, but that they are alive in the sense that matters most in science. They are changing, reacting, responding to gravity and sunlight and time in ways we are only now learning to measure with any real precision. The next great leap in understanding this might not even come from a brand new billion-dollar mission. It might come from patiently comparing pictures taken years apart, from professional observatories and from ordinary backyards, watching the same slow story keep unfolding one careful frame at a time, one clear night after another. So somewhere between now and the year 2032, when the rings swing back open to their widest, most magnificent angle in 15 years, find one clear night, step outside and look up, because the exact shape you see that night is one your grandchildren, and their grandchildren, will very likely never see in quite the same way again. Save this video, or bookmark tonight's date, because someday, decades from now, being able to say you understood exactly what you were looking at, back when the rings still looked like this, in the early 21st century, will matter more than you think it does right now. Somewhere in the next decade, a new generation of telescopes, both on the ground and in orbit around Earth, will turn toward Saturn with sharper eyes than Cassini ever had pointed back at it, and whatever they find will either confirm what O'Donoghue's team calculated back in 2018 or quietly rewrite it. Either way, the story keeps moving, the way every real scientific story does, never quite finished, always waiting for the next clear night, the next data point, the next small correction that makes the whole picture a little more accurate than it was before. Tomorrow night, somewhere on Earth, a person who's never even heard of ring rain will look through a telescope for the very first time, find Saturn by accident, and gasp. The exact same gasp people have been letting out for 400 years, without ever knowing that what they are looking at is quietly, slowly disappearing. You, on the other hand, now know something that gasp does not capture. You know the rings are not just beautiful, they are temporary, and that single fact turns an ordinary glance through a telescope into something closer to witnessing history while it is still being written. Saturn is not going anywhere, but the crown it wears right now, glittering, tilted, endlessly photographed by spacecraft and backyard telescopes alike, is running on a clock that started ticking long before any of us were born, and will keep ticking long after we are gone, one quiet swimming pool of ice at a time, falling gently into a giant golden planet that is still, after all these billions of years, full of surprises.